All right, so we're going to start off with lesson 2. So 10.2, it's going to be measuring angles and arcs. So the stuff we're going to do today, stuff we're going to do today is going to be to measure and identify central angles, major arcs, minor arcs, semicircles, and then find all of their measures. So we're doing all of this stuff for the very first objective today. Tomorrow, we'll do the second objective, where you'll be able to find the lengths of those arcs. All right, so the very first thing I want to just make sure we're all on the exact same page with. In a circle, do you remember how many degrees are in a circle? 360. Okay, for all you people who love the Olympics, okay, those people that are doing their flips and stuff on snowboards and whatnot, you got the 360s. So a circle is 360 degrees. Okay, I want to make sure that that's perfectly clear as we get started. A circle is going to be 360 degrees. Okay, so some of the definitions that we'll have that we'll start with. First one's going to be a central angle. A central angle is going to be the angle that has a vertex in the center of the circle. Yep. In the center of the circle, and the sides of that angle are going to be 2 radii of the circle. So it'll be a radius, and then this spot right down here, is the central angle that we're worried about. Okay, so that's going to be that central angle. If I wanted to have this central angle over here, like this one right here, how I would measure this central angle and how I would write it is I would put the measure, so the little M right there, of A, B, C. So I want the measure of angle ABC. Remember, the middle letter needs to be the vertex. And then usually we'll also throw a little arc over the top. But yeah, we're finding the measure of angle ABC, or we could also do just angle ABC, because it is going to be an angle. Okay, we already talked it before, and again, it's not limited to just 3 angles. But what it's saying is that the sum of every single angle, it could be 2 angles, it could be 3 angles, it could be 10 angles. The sum of all of these angles added together is always going to equal 360 degrees. So a circle like that is going to equal 360 degrees. If I had a circle that looked like this, okay, I'm going to say this is 1, 2, 3, 4, 5, 6, and 7. That tells me that angles 1, 2, 3, 4, 5, 6, and 7. If I added every single one of those up together, that's going to equal 360 degrees. No matter what, that's how many degrees are inside of a circle. Make sense? Okay, so as long as you guys get that part, then this lesson shouldn't be too bad. Okay, so the first one I'm going to do by myself. Second one, you guys will help me. Third one, you guys will do on your own. I've got this circle right here. Altogether, this circle I know is going to equal 360 degrees. So if I wanted to solve it, I'm going to do 165 plus 145 plus x. All of that is going to equal 360 degrees. All right, so I'll take 165 plus 145. I get 310 plus x equals 360. Subtract 310 from both sides. I know that x in this equation is going to equal 50 degrees. Again, I know that whole entire circle, no matter what, every single angle is always going to add up to 360 degrees. So far, so good? Okay. Of course, I can't make it super easy like that every time. So I got a lot of stuff going on. I'll zoom in, so if you want to write that down, you may. All right, so as I'm looking at this whole entire circle, I've got this piece, I've got this piece, I've got this piece, I've got this piece. I don't have this one. Okay, so I don't have this one. I can't have everything add up to 360 degrees. But RV, this line right here, is a diameter. If that's a diameter, that means it cut that circle perfectly in half. So if the circle got cut in half, how many degrees is this part that I highlighted yellow? Or how can we figure out how many degrees that whole entire thing is going to be? Perfect. Yeah, we're going to take 360 degrees divided by 2. Okay, let me get my different pen out here. I'm going to take 360 divided by 2. That tells me that half of a circle is going to be 180 degrees. Okay, channel your inner Olympics and remember like the skateboarders, they only do like a half twist. It's a 180. What I'm talking about? No. Anyway, so I got half of that circle is going to be 180 degrees. Now that I have that, now I can put these things together to solve it. I'm going to take everything that's inside that yellow half of the circle. I can take 8x minus 4 plus 13x minus 3 plus 5x plus 5. All of that's going to be equal to what? 180, yeah. Now I get to combine my like terms. I've got an 8x, I've got a 13x, I've got a 5x. All of those put together is going to be 8 plus 13, that's 21. 5x is going to be 26, so I've got a 26x. I've got negative 4 plus negative 3 plus 5. All right, so I've got -8 plus 5. That should give me a -3. Did I do that right? Just going to double check for myself just to make sure I didn't screw something up. -2. Nobody caught me on that? All right, -2. Yeah, that's better. Somebody talk me through what's my next step to do. Yeah, we're just going to get that x on the side by itself. So I'm going to add 2 to both sides, plus 2. I got 26x equals 182. I want to get x by itself. So what will I do to get x by itself? Divide both sides by 26. Fantastic. So I've got 182 divided by 26. My x value is going to equal 7. Again, lots of steps for that part, but as long as you can figure out either the full circle is going to be 360, half of a circle is going to be 180, you'll be set. Okay, I'm going to give you one of them real quick. Ugh, this is going to be a diameter. Just go with it. Okay, I want you to figure out what x is going to equal. Yep. These are on the same side, right? So we can combine those. Not quite. These ones get added together. So it'd be 3x plus the 2x. 5x. Yes, sir. Yes, sir. Yes, sir. Perfect. I watched what you guys are doing. It was great. There's 2 ways to solve this one. Okay, if you saw that as a diameter, I was going to make sure that I had 180 degrees plus 3x plus 2x equals 360. Okay, minus that 180 to both sides. You would add 5x equals 180. Okay, after this, we're going to divide both sides by 5. X equals 36. Some of you guys started off with just half that circle. You saw that there was a diameter, and you did not need to do the entire circle. If you did that, you would have had it as 3x plus 2x equals 180. Combine like terms, you would add 5x equals 180. Hopefully, at that point, you see that these two are the exact same thing. So if you figured it out for the whole circle, that was fine. If you figured it out and you saw that it was only going to be half the circle, that's going to be fine as well. Okay. So far, so good? Love it. Okay. We've got another definition that's going to come into there. We've got an arc. An arc is going to be a portion of a circle that's defined by two endpoints. Okay? So again, the arc is going to be the distance around the outside. That would be an arc. This would be an arc. That's an arc. And that's an arc. All right, but when I write this, or when you see this, if I were just to tell you I have angle PQR, because it's in a circle, I don't know which one they're talking about. Because again, PQR, that's this angle, but it's also this angle on this side. So we can distinguish those in two separate ways. We can call it a minor arc, minor being smaller than 180 degrees, or a major arc is going to be greater than 180 degrees. To help you remember that, you just get rid of that last zero. You're a minor when you're less than 18, right? Yeah. So if you're less than 18, you're a minor. If you're bigger than that, then you're a major. Okay? But that's just the easy way to remember what the minor part is. Okay? That's exactly what this thing is. Don't worry about the extra definitions. If you really want it, you can. But the last definition that's going to be not new, but you'll know. We already worked on it, but I didn't give it a name yet. If we only do half of the circle, just the diameter, cut it straight in half, instead of calling it a half circle, we call it a semicircle. Super. Okay, this will be kind of the last part we're going to work on. It'll be a little bit of the same things here. Okay, so PM, we'll kind of go here. PM is going to be a diameter. That means that this line here is cutting straight across. I can't draw a straight line, but you get the idea. This one here is a straight line that goes straight across. So all the angles on this side are going to be how many degrees? 180. All the ones on this side will be also 180. Okay? So one thing that I will usually do first is I'll draw this picture and I will put in all my angles. So that way I can just do my extra math a little bit later on a lot quicker. All right, let's start talking some things. PRN, this angle right here, how many degrees is that? You can tell because this little square thing. 90 degrees. I know this one's 90. Okay, NRM, this part down here will be how many degrees? 90 as well. Yeah, because again, it's a straight line. This is the stuff we did a couple chapters ago. So the only segment I don't know yet is going to be MRQ. How can I figure out this angle?
180 minus 115.
Fantastic. I'm going to take 180 minus 115. So 180 minus 115. I am left with 65 degrees. I know every single angle inside this circle now. As soon as I know every angle inside that circle, I can answer these questions a whole lot quicker. Okay? So it's saying it wants us to identify it as a major arc, a minor arc, or a semicircle, then find the measure. We found the angles first, so we can kind of do them quick. MQ. First off, MQ, is that a major arc or a minor arc? This part here. Is it, how much of this did I go further around, or did I just do a smaller little? Yeah, unless it goes over half of the circle, it's a major. So if it's less than that, this will be a minor. So I've got this one's a minor. Okay, and then how many degrees is that one? 65 degrees. Okay, let me erase that part. I'm going to get my highlighter out for these next couple, just to show what's going on. Letter B. It is saying it wants me to find MNP. When it gives me those letters, I start on the outside and I work my way around according to the letters they give me. M to N, N to P. I'm doing that entire part. So out of this portion here, minor, major, or semicircle? There it is. Semicircle. It's just half of that circle, so it's a semicircle. If it's a semicircle, how many degrees is it? 180, yeah. Or if you weren't 100% certain, you could take 90 plus 90. Super duper. Okay, I'm going to do this next one. Let me get the highlighter back out. This next one says MNQ. So again, we're starting at M, we're going to N, and then from N it's going to Q without turning back on itself. So it's going to be that entire segment. For that one, a minor, major, or semicircle? Major. It's going more than half the circle. So that's going to be a major. And then to find that degree, what will we do? Again, we already wrote this stuff down. I'm just going to add every single degree or every single angle that's within that highlighted segment. So I've got 90 plus 90, which is 180 plus 115. So I've got 180 plus 115. That whole entire segment, all the way around that, is going to be 295 degrees. Kind of making sense? Feeling pretty good? Okay, I'm not gonna fight too much on the degrees right now. These ones are just gonna be 90, 90, and 180, so it's pretty simple. So we'll look at this first one. I just want you to tell me minor, major, or semicircle without going through. X, Z, and then Y. So X is up here, Z, and then down to Y. What's that one? You guys can all say it. Semicircle. Fantastic. So that's a semi. W, Z, X. So W to Z, and then Z. Oh, sorry. I did it backwards. W to Z, and then Z to X. Without having to go back on itself. Major, minor, or semi? Major. And the last one, XW. You're not erasing. XW is here. Minor, major, or semi? Minor. Okay. That is all I wanted to go through today. Don't worry about that definition. What I have for you guys, page 710, 12 through 21 all. Again, if you draw that whole circle, fill in all the angles, that will make the last parts go really, really quick.